Hello, this is lesson 8.4, angle relationships. So we're going to be working in the book from pages 251 to 253. This is part 1 of the lesson, and our next video will be part 2 of the lesson. So let's talk about our standard. We are now in geometry, which we have been working in. So our standard for today is G5. I can use facts about supplementary, complementary, vertical, and adjacent angles in a multi-step problem to write and solve simple equations for an unknown angle in a figure. We're going to get to all of that standard as 2 parts. So today we're just going to be talking about what the different types of angles are and how to figure out their measurements. So we first have to start with a lot of definitions. So hang in there, I will be sharing this with you, but you do need to know these. So first let's start with an angle. What is an angle? Well, an angle is the space, I'm going to grab a line here, the space between 2 intersecting lines. So here is one line, here is the other. They intersect, they hit at this point here. Let me grab a thing here. This point where they meet is called the vertex. And angles are measured in degrees. So if I want to grab, let's see here. So this here is the angle right there. And this is going to be measured in a little thing called a degree. It looks like a little circle with an open circle. Right angles. So now I'm going to clear my drawing. So a right angle is an angle formed where 2 perpendicular lines meet, or where 2 lines meet to form a perpendicular angle. Right angles measure 90 degrees. So this little box here in the corner, that's a symbol of a 90-degree angle. And you're going to be using that a lot from now on, all the way through your geometry class in 10th grade. So this little box means it's a 90-degree angle. It's perpendicular. This line and this line meet exactly at a 90-degree angle. So that's a right angle. What is an acute angle? Let's move down to acute. That is an angle that is less than 90 degrees. So I always like to think of it as a cute angle. It's little, it's cute. Think of little kids, they're cute and little. So an acute angle is very cute. It's little. So if you want to take an example, let me just take this for a second. If I was to move this over into the 90-degree angle, you can see, and if I turn it just a little bit, you can see that it's less than 90 degrees. So an acute angle is less than 90 degrees. I could technically move this line all the way up here, oops, all the way up until I hit that, and then it would be 90 degrees. So anything below this is an acute angle. Okay? I want that to happen. I want the whole thing to move back where it was for you guys. So the acute angle, remember the measurement is the inside part right here. Okay? Then we have an obtuse angle, and I always like to think of obtuse angles. Obtuse means greater than 90 degrees. I always like to think of obtuse angles as, think about the word obese. They both got the OB in there. You think of an obese person, you think of somebody that's rather large. So an obtuse angle is an angle that is greater than 90 degrees. So if I were to take this angle and put it up here and turn it just a little bit, you can see that this line here is past the 90-degree line. So it's bigger than 90 degrees. I would guess that's maybe about 100 degrees. So it's just an estimate. But you could use a protractor, which we're going to do today, to figure out exactly how big an angle is. So now, why did my 90 degrees move with it? It wasn't supposed to. Oh, I see, it didn't. It just did this. I'll put it down here. Okay. So that is an obtuse angle. So acute, little, cute, less than 90. Obtuse, bigger than 90. Think of obese. Okay, angles in a circle. So if I were to take a line and draw it right through the center of my circle, I'm going to try to guess where the center is. right there, okay? And then I were to do that again, exactly through the center. Do you know the measurement of this angle right here? Well, doesn't it look like it's a perpendicular line? And it is. So it actually, I'm going to put a little symbol there. It's a 90-degree angle. So we know that this angle is 90 degrees. What is this angle here? Isn't that also another perpendicular line there with another perpendicular line? Try to make my little symbol there to be the same size. There. It's almost the same size. So yes, this angle here is also 90 degrees. And I'm going to put this on here. This is also 90 degrees. So what is 90 plus 90? What would this whole line be? 90 plus 90 is equal to 180 degrees. So if you actually look below, angles in a line, a whole line, an angle, all angles in a line, we're going to equal 180 degrees. So a line always equals 180 degrees. A super important thing to keep in mind whenever you're working with geometry and angles. So this line here, grab my little spotlight here, this line here is 180 degrees. Why? Because it's formed with two 90-degree angles, right? What about this angle here? This one right here. Isn't that also a 90-degree angle? So we're going to put a little symbol there. Another 90-degree angle. And as you guessed, the last angle is also 90 degrees as well. So let's put that in there. This is 90 degrees. It's not always the easiest to do on the computer, but it's okay. Okay, so I have in a circle a 90-degree angle plus another 90-degree angle plus another 90-degree angle plus another 90-degree angle. How much do all those angles measure or add up to? Exactly, a circle has a degree measurement of 360 degrees. Super important. This will be used for all of your angle measuring things that you do in geometry, as well as trigonometry when you get to that in high school. So you have to know that a circle is 360 degrees. All the way around this circle is 360 degrees. Why? Because it's composed of four 90-degree angles. And if you add up all the angles, you have a circle 360 degrees. Okay, I'm going to have to clear my drawings. Move up to the angles in a line. We said they were 180 degrees for a straight line. I'm going to write that back again. I'm just going to put angles in a line are 180 degrees. And just know when I share you these notes, anything that I draw on the screen does not show up on the notes. So if you want to write that down, you can. So now if I were to take a line and go like, I want a line, not that. I want an actual line, not a goofy thing. So if I were to take this and draw that line, move it down just a little bit, I have 2 points that intersect, 2 lines that intersect, so I actually have an angle formed right here, and I have another angle formed right over here. Now I know that this angle is it acute or is it obtuse? This angle right here. We'll call that angle A. Angle A. Acute or obtuse? Yes, that is an acute angle. It is less than 90 degrees, so that is acute. I probably should have typed that one in instead of trying to write that by hand. So that's an acute angle. What about this angle right here? Is that acute or obtuse? Exactly, that is obtuse. Obtuse. It's more than 90 degrees. So that's an obtuse angle. Now I know that, and I'll call this angle, we'll call it angle O for obtuse. And I know that angle O plus angle A equals, you guessed it, 180 degrees. So I'll type that. I won't be able to. Angle A plus, and this is how you designate it, that little symbol means angle. Angle O equals, check my hand out there, 180 degrees. Because we have a line, and didn't I tell you a line is 180 degrees? Yes. I could also move let me clear my drawings. Well, let's not clear all of them. Let's just clear this one, that. Right here. Oh, I cleared it by mistake. What if I took my line and I went this way? Would these two angles that are formed right here, oh, not a line, I want a drawing. These two angles that are formed right here and right here, wouldn't they also equal 180 degrees? Exactly. So you can take, and I could take this line here, and I could move it down this way, and I'd still have two angles that measure 180 degrees. I could go this way, I could go way down here. I have a huge obtuse one and a little tiny acute one. They would still always be 180 degrees. Okay, let's do some more definitions. Let's move up to congruent angles. Congruent angles are angles that have the same measure. Congruent is a word that you're going to use a lot in geometry. So the angles in this example here are congruent. This angle is the same size as this angle. They're turned differently, but they still measure the same degrees. And we'll get into measuring angles in just a minute. Okay, adjacent angles are angles that share a vertex and one side, but they do not overlap. We kind of talked about that when we did the line just a minute ago. They are two angles that are next to each other. So, adjacent angles. This angle here is adjacent to this angle here. They share a side, but they do not overlap. So they're adjacent. And also that some of those two angles happens to be 180 degrees. Okay. Let's move on. Vertical angles. They're angles that are formed from opposite sides of each other by intersecting lines. So this line here intersects with this line here, and the vertical angles that are formed would be this vertical angle and this vertical angle, right? You also have this vertical angle and this vertical angle. So vertical angles are always congruent. Another super important fact that will help you a ton when you get to geometry. So that means that this angle here, angle BFD, is congruent or equal to angle AFE. Also, clear that again, these two vertical angles are also congruent. Angle BFA is congruent to angle DFE. Okay, another important thing to keep in mind when you're figuring out these things. Complementary angles. They're two angles who measure the sum of 90 degrees. So we know that we have a right angle right here, right? This angle with the little box is 90 degrees. If I was to draw this line, which I have here, in between there, I have formed an angle here, and I have formed another angle here, right? The sum of this angle plus the sum of this angle is equal to, you guessed it, 90 degrees. Just like when we had our line, I'll go back up there for just a minute. When we had our line up here, the two angles that are adjacent to each other equals 180. When you have two angles here that are adjacent to each other within a 90-degree angle, the two angles will measure, the sum of the two angles will measure 90 degrees. So maybe this one is probably, I'm just going to guess, maybe this is 30 degrees. And the other one then would have to be 60. Probably more 45 and 45 the way I drew it, but you get the idea. 60 plus 30, 60, yeah, 90 degrees. Okay, supplementary angles are two angles whose measures have a sum of 180 degrees. We've already kind of talked about that one. This angle is maybe, it's under 90 because it's less than 90. You can say maybe this one's 60. Then what would the other one have to be? Because they have to equal 180 because a line always equals 180. So it'd be 180 minus 60, right? Minus 60, which would give you 120, right? So the other angle, and it is obtuse, it's over 90, would probably be 120 degrees. Now we don't know for sure because we haven't measured it, but we do know that it will add up to 180, and that looks, eyeballing it, about right. The geometry you can't always eyeball, just so you know, but there are lots of proofs and theorems that you can use to find out the measures of angles. Let's see if there's more. Yes, okay. How to name angles. So you can name angles in a couple of different ways. You can call it angle A, that's where the point is at the vertex here. You can call it angle B over here, or you could call it angle C. That's one way to measure angle, or to name angles. Another way, which is used more often, especially when you get a weird shaped diagram like this with all different lines intersecting in all different ways, you have to start naming your angles like this. Angle AFB. So let's see what that is. Angle AFB. The vertex is always the center letter. So F is my vertex of angle AFB. Then you have angle DFE. Angle DFE. So that's what? What angle is DFE? Well, that's this angle right here, right? Can't call it angle F because you don't know which one you're talking about. You could be talking about this one, that one, that one, or that one. You have to use three letters to name it. Angle AFE. AFE. So F is in the center, so that's this angle right here. And you'll get used to this. Geometry with angles is a lot of this. Angle ABC is congruent to angle DEF, but it's also vertical to angle GFE, whatever. There's a lot of that angle stuff that you're going to be doing. So you'll get used to it. Angle AFE, angle AFE, okay, and then angle BFD, BFD. Be careful on this one. There's a line in between it, right? But angle BFD is actually this whole thing right here, right? Now, can you tell a pair of vertical angles from this picture? I think we're going to ask you that again in a moment, but yeah, angle BFD is vertical to angle AFE. And we know that vertical angles are equal in measure, so we could say that angle BFD is congruent to angle AFE. Okay? Keep that in mind. Let's move down here. Now we've got our diagram again. We've also got a measurement here. So, and we've got another line intersecting here, which forms another angle in between our 90-degree angle. So we are going to try to find some angles here. I'm going to move my little chart up here a little bit, see if we can get the whole thing to show almost. Name a right angle. Okay, you look for that little square in the corner. And remember how we name angles when you got a whole bunch of stuff going on here? So we have the right angle is angle CFD. And maybe I should draw that. Angle CFD. That is our right angle. So let's put that as our answer here. And I'm going to use, I would like to use a different color to designate that. There we go. Red. Okay. Right here. Okay, so that is angle CFD. Remember the F, the vertex, is always the center letter when you're naming angles. So name a right angle, angle CFD. Okay, I'm going to clear my thing, get extra things out of there. The next one, name two complementary angles. What are complementary angles? Complementary angles are angles that together their sum measures 90 degrees. Can you find two angles there that will measure 90 degrees? Well, of course, you can find angle DF, and this G is supposed to be moved over here. DFG and angle GFC. I'm going to actually move that G, if it lets me, move that G a little bit closer to the line where it should be. Okay, good. Okay, you can go away there. Okay, so two complementary angles then, and I'll draw them, would be angle DFG, and you add that to angle GFC. Those two angles are complementary. So then if I wanted to answer that question, we could say angle DFG, remember the F goes in the center, it's the vertex, and angle GFC are complementary. Their sum equals 90 degrees. Could I have called this angle here, I called the GFC. Could I have called it angle CFG? I still have F in the center as the vertex, so it doesn't matter if I put C first or if I put G first, but I have to put F in the center. I couldn't call this angle CGF. I couldn't do that. I have to have the F in the center. And I did want to make that red as well so you can see that. And that did not work. There we go. Okay, next one. Name a pair of, let's erase our red lines again. Name a pair of vertical angles. Okay, now we have vertical angles. So the vertical angles are angles that are directly across from each other where two lines intersect. So it's a little weird. We got to look through this a little bit. Well, we know that this angle AFE, angle AFE is vertical to what? Angle BFD. I kind of look past all those things in the middle. So angle BFD is vertical to angle AFE. See that? And they're also congruent. They're the same size. Okay? Same measurement. So name a pair of vertical angles. We had angle AF, oops, where'd my angle symbol go? Angle AFE and angle BFD. And I'll put that in red so you can see that. Okay. Name a pair of adjacent angles. Oh, by the way, before I go on to adjacent, what other two angles would be vertical angles here? We're not going to write that, but can you see on the diagram which ones would be, which other ones would be vertical angles? Yeah, exactly. You can see that this angle BFA is vertical to angle DFE, and they're also congruent. So wanted you to just kind of see that there's more than one answer a lot of times. Okay, the next one, name a pair of adjacent angles. Adjacent angles are angles that are next to each other that share a side, but they do not overlap. So I could find adjacent angle, let's see, CFD is adjacent to CFA, right? So that means that this angle, CFD, is adjacent to CFA. And what measurement do those angles measure? 180, because they're a line, right? They're on a line. So they measure 180 total together. So let's put that in there. Name a pair of adjacent angles we decided was DFC C, the angle sign there, and CFA, angle sign. CFA, and then let's highlight that in red. Okay, are there any other adjacent angles in that diagram? Let's clear our lines and see if we've got any other. Well, we sure do. Hopefully you're seeing that at home. You can see that we have angle AFE is adjacent to angle EFT. So the sum of this angle here is equal, and this angle, the sum of those two angles is 180 degrees. And I'm trying to see if there's any other adjacent angles, and actually there are. Do you see them? Can you see them on the computer there? Or on your phone, whatever you're on there? Did you notice that angle BFC is adjacent to angle CFE? Look at that. Those two angles, this one here is adjacent to this one, and when you add the sum up, you get 180 degrees. So we actually could figure out the measure of this angle and be exactly right. How could we do that? Well, we already know that this one is 50, right? We know that this angle here is 50, and we know that the whole line has to be 180. So what does this angle have to be? 180 minus the 50 that's already been used up, right? What's 180 minus 50? 130. And it makes sense because it has to be obtuse because it's greater than 90. You can tell that right here. It's leaning, right? So it's 130 degrees. So name a pair of supplementary angles. Well, that was adjacent. Okay, supplementary angles are two angles that add up to 180 degrees. Well, we just found 3 sets of them, didn't we? So we use the one that's on the board right now. We will use angle BFC is supplementary to angle CFE because together they equal 180 degrees. So let's put that in there. Angle BFC is supplementary to angle CFE. I'll put that in red, hopefully, my goal. Okay. Make sense so far? All right, I'm going to clear all these extra businesses here so we can see the next one. Now it says, name 2 pairs of supplementary angles that include, and this got put in the wrong, that include angle DFE. Move up a little bit. I hope we can get this all on the screen. Name 2 pairs of supplementary angles that include angle DFE. Well, let's go figure out what angle DFE is. Angle DFE. Name 2 pairs of supplementary angles that include DFE. Well, what other angle includes DFE? Well, AFE, right? That will equal 180 because you got the line here, right? Name 2 pairs of supplementary angles that include DFE. So that one we know. And we also know that let me get rid of this now. DFE is also supplementary to DFB, which is what we were just doing. So we can name 2 other pairs of supplementary angles. It would just say, we could say angle DFE and angle EFA, and also angle DFE and angle DFB. Hopefully I didn't confuse you with all that, but take a look at it at home or rewind the video and I think it'll start to make sense to you. Okay? Get rid of all our extra red lines, and now I have to scroll a little bit to get the last question on this page. Are angles AFC and BFC adjacent angles? Why or why not? Let's find the angles. Angle AFC, angle AF or C. I think C is the one up here. You can't see. You can kind of see that. You can see that. Angle AFC and angle BFC. Are they adjacent angles? AFC and BFC. Are they adjacent? Well, they overlap, don't they? So no, they are not adjacent because they overlap. If you notice, this angle here, let me grab my spotlight. This angle here overlaps this bigger angle. So it's actually kind of inside of this bigger angle. So they are not adjacent. So the answer is no. No, they are not adjacent because they overlap. And I'll put that in red right here so you can see that. Come on, there it goes. And then I'll clear my drawings. Okay, so here are the answers to this diagram. I would strongly suggest going back and reviewing it if it's confusing to you so that you can get a handle on what the different names are for the angles and how they interconnect and how they are talked about with geometry and how they are measured. All right, let's go to the next page here. We have the same diagram, except I didn't put in the extra little blue line, if you notice. So this diagram, we're going to answer a few more questions now. What is the sum of angle CFD? So let's go find that. You always, with geometry, have to go and look at the picture. So angle CFD, remember F, the center letter is the vertex, plus angle CFA. So far we've got this angle here, which we know is how much? How many degrees? We know it's 90 because of the box, right? It's perpendicular. And then this angle plus angle AFE, and let's draw that. That's angle AFE. And the final angle DFE. So let's do that one. That's DFE. That's already drawn for us, DFE. So that's the angle right here. Okay, what is the sum of those four angles? I bet you can tell, right? Exactly, it is a circle. All these angles together makes a circle. And what did we say that a circle's degrees measure? 360. So we'll replace our question mark with 360, and the little degree symbol is somewhere off here. Right there, 360 degrees. So let's highlight that in red. So that's why a circle is always 360 degrees. It forms from four angles. So the angle measure, so if you add up the sum of CFD, CFA, AFE, and DFE, you get 360 degrees. Okay, what is the measure? Let's clear that. What is the measure of angle AFB? We gotta find it. Angle AFB. What is the measurement of that angle? Boy, it's a little bit tricky, isn't it? But it isn't if you really look at it. Well, what do we know? We know that this angle, well, let me draw the line. I'll use spotlight. That this angle here, oops, move my, this angle here, CFD, how many degrees is CFD? It's perpendicular lines, 90 degrees. So we know that this is 90 degrees. Right? Move that a little closer. And we know that this is 50 degrees, right? It tells us. A lot of times it'll have to tell you one of the angles. So what is the measure of AFB? So what is the measure of this little bit right here? How can we find that out? Well, if you notice, don't we have a line right here? So we know that the sum of all of these three angles has to equal 180 degrees. So we know that out of the 180 that we need, we know one of them is 90 and one of them is 50. What does this have to be? Well, how could we figure that out? Well, we know we have 180 has got to be our total, equals 180. Move it over. We could make an equation for ourselves, and that's what we're going to do. So we have 90 plus 50 plus x, I'll fix that in a minute here, equals 180 degrees. Thought we were done with equations, didn't you? Not really. Okay, so 90 plus 50 plus 180, I can't move this because it moves everything, plus x equals 180. So 90 plus 50 is 140. So put that over here. 140 plus x is equal to 180. What do I do to get x by itself? I subtract 140 from both sides. And this, by now, you guys should be pretty good at this. If I do that, the 140s will cross off. I'll use a different color here. 140s will cross off. And I'm left with just x equals 180 minus 140. Should be 40 degrees, right? 40 degrees. So my measurement then is 40 degrees. I'll go back up here. What was the measure of angle AFB? Well, we can put it in now. We know it's 40 degrees. How do we know that? Well, 40 plus 50 plus 90 should give us 180 degrees. So that is how we do that kind of a problem. Okay, I'll just clear all my drawings. Let's look at what is the relationship between, I'm just going to get rid of this extra space here. What is the relationship between AFB and BFC? Okay, AFB, let's figure that out. No, I wanted to use my red, not red. Okay. AF, computer things. Okay. AFB, right here. What's the relationship between AFB and BFC? Tricky. What's the relationship between this angle and this angle? Well, what do we know? We can look around, and we know geometry is all about looking around at the diagram. This angle here we already know is 90, right? Because it's a little box and it's perpendicular. And if this is 90 and we know that this whole line has to equal 180, right? So we have this angle here, I can show that. This angle here, I'll pick a different color. Right here is 90. What does this whole angle here have to be? 180 minus 90 is 90, right? So this angle is also 90 degrees, correct? So we know that, we can put a little box there. We know that this angle here, it's not going to be the right direction, but this angle here is, oh, I don't think I can rotate it. No, I can't. It's 90 degrees. So if this is 50, this has to be, and we already figured it out, but it has to be 40, because 50 plus 40 is 90. So what is the relationship between those angles, AFB, and BFC? They are, what's the word? The angles are complementary, right? Or their sum equals 90 degrees, correct? So let's put that in red so you can see that. There you are. Okay, now I want to go under the document camera and I want to do some measurement of angles, and then I want to do a little bit more of what we've done, and then we'll come back here. So if you need to pause it or rewind it to see things, go right ahead, and I will meet you under the doc camera in a moment. Okay, here we are under the document camera, and I have my homemade protractor here. Hopefully you can kind of see that. So if you don't have a protractor at home, you can make one by printing one off on the internet. So let's see. We want to measure, we want to know the measure, that M stands for measure, measure of angle 1. Angle 1 is this, right here. We didn't do letters this time, we just did numbers. So measure of angle 1, and this is actually in your book on page 251. I'm not doing all of it, I'm doing part of it. So when you measure something with a protractor, you have this, I don't know if you can see that little hole or a little dot in the center, and then you have this line, and you have a line going there. That's exactly perpendicular there. So you have to have this line and this hole measure up on the vertex. So if I'm measuring angle 1, I'm going to put my hole, and maybe I'll put a little circle around my hole so you can see that. My hole has to be on the vertex right here, and then I have to make my line so that it lines up with my line that's one of the sides of my angle. So I'm going to do that exactly as best I can. And now I want to measure, you can see that behind it. This is the side of my angle, and here's the other side of my angle. It's kind of hidden by the protractor, but it's right there. So what is the measure? Well, you've got this straight line lined up with the side of your angle, and you've got your center and your vertex. You follow this line up, and then there's two numbers, if you notice. There's a 70 and 110. So we have to decide if we use the 70 or the 110 to measure this angle. Well, if the angle is obtuse, it's going to be more than 90, right? If the angle is acute, it's going to be less than 90. So if I was to draw, this is 90 right here, right? So my 90-degree angle would be right there, right? My line would hit it there. So we can see that this purple line is past the 90, right? So we're going to use the number that's bigger than 90. We're going to use the 110. So measure of angle 1 then is 110. So we're going to write that down here. Measure of angle 1 is equal to 110, and again it's in degrees. What is the measure of angle 2? We're going to do the same thing. We're going to put our center right on the vertex, and this time we have to have our line in straight on this side, because angle 2 is this one now. It's this angle right here. So we put our vertex, our hole on our vertex, and we line it up right like this. We also already kind of can tell what the number should be because we figured out the 110, right? And we know, let me just take it away for a minute. We know that angles 1 and 2 are adjacent, and they're also on a line. And we know angle 1 is 110. We know that together they have to equal 180. So what would that give you? This has to be 70, doesn't it? Let's see if we get it right. So let's measure it. Do it right. Should try to do it exactly right there. Not perfect, but there it is. Okay, so we're on the line. We go up here, and we can either pick, oh, you can't see that. We're either going to pick 70 or 110. And because 90 is here, this line here, the side of our angle is less than 90. So we're going to take the smaller number, the one that's less than 90, it's 70. So that measure of angle 2 is equal to 70 degrees, and that goes along with our total, right? Angles 1, do all this at once. Angle 1 and angle 2 are adjacent and they're on a line. So they have to equal 180. So does 110 plus 70 equal 180? Yes. Together they equal 180 degrees, right? So we know we measured it right with our protractor. Let's look at the measure of angle 3. 3 is right here. That's this part right there. So we're going to take our hole of our protractor and put it on the vertex. Then this line has to line up with one of the sides of our angle, so either this side or this side. I'm going to turn it so that it lines up with this side. Try to get it right on the center here. And lined up exactly right. So our line is hitting here. It's either going to be the 80 or the 100. Hopefully you can see that. It's either going to be 80 or 100. So here's my 90. So I have an angle that's a little bigger than 90, so I'm going to take the number that's above 90, 100. So measure of angle 3 then is 100 degrees. And hopefully you did some of this in 6th grade. So you should know how to measure angles, but I don't know. So measure of angle 4 is right here. Again, we're going to put our hole on our vertex, and then our straight line has to line up with one of the sides. I'm going to pick this. By the way, you should already know what this angle measures, right? Without even having to measure it. Why? Because you know the angles 3 and 4. 3 and 4 are on this line, right? And 3 and 4 have to equal 180. We already know that 3 equals 100. So what does it 4 have to equal? Well, 4 has to equal 80 degrees, right? So let's line this up right. Here's our line. And it's pointing to the 100 or the 80. And we know that 90 is here and it's less than 90. So we're going to take the 80. So that's 80 degrees, which we already know. So 100, 3 and 4. Get it up there. 3 and 4 are on a line. They're adjacent. They have to equal 180 degrees. Now, what else could we know? What if I had just measured angle 1? Could I tell what angle 3 is if I knew what angle 1 was? Yes, because they are vertical angles. And what do we know about vertical angles? Vertical angles are the same size. They're congruent. And this didn't work out exactly right on my picture, did it? 1 and 3 should be both 100. So I must have measured a little bit off because of my ruler. And these two angles should be the same. So they should be both 80 or both 70. So bad example of how my lines didn't work out, but they should be the same. Okay, the measure of angle 1 plus the measure of angle 2 we've already done. They equal 180 degrees. The measure of angle 2 and 3 have to equal 180 degrees. Angles 3 and 4 have to equal 180 degrees. And angles 4 and 1 are on a line. They have to equal 180 degrees. I must have measured wrong on something there. Yeah, I think my measure of angle 1 is off. I think that's what it was. Let's see what measure of angle 1 is again. It should be 100. I must have turned it wrong. Yeah, I turned it a little off. So it should be 100. So my measure of angle 1 should be 100, and my measure of angle 2 should be 80. There, I fixed it. So they should all equal 180, okay? This is my homemade protractor, so it's not exactly accurate. All right, next I want to do page 253, your turn. So that's what I'm going to pull up now. Hang in there. We are almost done for this video. All right, this is your turn, page 253, and I don't think I can get the whole thing in there. But you can see them in your book if you follow along. The same questions in your book, number 5, 6, 7, 8, and 9. So number 5 is name a pair of supplementary angles. So we'll go back and just keep it on the diagram here. Supplementary means what? What does supplementary angles mean? Supplementary means they will equal 180 degrees, right? Yes? AG, what do they do? AGC and FG. Okay, so supplementary angles, there's several we could pick from, right? Any two angles that are on a line. Here's a line, here's a line, here's a line. So we could take these two, FGA is on the line of AGC, right? Don't get mixed up with this one in between. So this angle and then this angle right here and right there is on a line, right? So they're supplementary. So we will say that number 5, the pair of supplementary angles is angle FGA and AGC. Okay, FGA and AGC. There are others. We could pick EGF and FGB, right? Or we could do FGE and EGC. You can pick any of those, right? Number 6, name a pair of vertical angles. Vertical angles are opposite of each other. Well, we could pick AGB, this one here, and EGD, that one there, and they should both be 90. This is also a 90-degree angle, it's just upside down. So let's pick that. So angle AGB, angle AGB. Again, remember our vertex is our center letter. And what other ones are vertical? We said AGB and EGD. Angle EGD. Are there other vertical angles that you could find? Of course. There's lots of different ones, right? How about AGE and BGD? Notice how vertical angles will have the same center letter. AGE, BGD. They are also vertical angles. Okay, number 7. Name a pair of adjacent angles. Angles that are next to each other but do not overlap. Adjacent angles. Well, we could use what we used before, FGA and AGC, but we could also use FGA and AGB. Aren't they adjacent to each other? This angle is adjacent to that angle, or this angle is adjacent to this whole angle here. Or we could say CGD, this angle is adjacent to DGE right here, or CGD, this one, is adjacent to this whole other angle right here, DGF. So we could pick any of those. There's more. Let's pick a few. So let's pick we're going to pick AGB and BGC. Okay? Angle AGB is adjacent to angle BGC. Okay? Many more you could pick. Number 8, name a pair of complementary angles. Complementary angles are angles that when next to each other will add up to 90 degrees. So they don't have to be next to each other, just have to add up to 90 degrees. So do we have any angles that add up to 90 degrees? Got to look at this one a little bit. We see this little 90-degree symbol here in the corner, and we know that this whole thing is on a line, right? So we know if this angle here is 90, this angle here has to be 90, right? Because 90 plus 90 equals 180. So can you tell me two angles that together will add up to 90 degrees? Well, how about FGE and FGA? Don't they add up to 90 degrees? They have to, right? Based on our picture. So what, name a pair of complementary angles? Complementary angles would be angles EGF and angles FGA. Name a pair of complementary angles. But now look at this. If you know that this is 90 degrees, you also know that what else is 90 degrees? This is 90 degrees, and that is 90 degrees. So you can find another set over here of complementary angles right there. You could have said DGC and CGB. Okay, and the last one, find the measure of angle CGD. Let's figure out where that is. CGD. So we want to know the measure of this angle right here. Okay, so we got to know a bunch of stuff. We already kind of talked about it a little bit. Well, we can do this a couple of different ways. We know that this is 90 degrees right here because this is on a line and they're adjacent. If this is 90 degrees, this whole thing has to be 90 degrees, right? We know what this angle is then. What's that angle right here, this little teeny one here? If the whole thing is 90 and this says 35, what's 90 minus 35? 90 minus 35 is what? 55, right? So this right here is 55 degrees. Now the question was, we're trying to find the measure of angle CGD. CGD. We're trying to find the measure of this one. Do you notice anything? Are there anything vertical? Maybe. We know that this here is 90, right? And we know that this here is also 90. Wouldn't you say that this angle that we said was 55, it's hard to see that, is also vertical to this angle right here that's 55 degrees? Aren't they vertical? Yes, they're vertical angles, and we know that vertical angles are congruent. So this has to be 55 degrees. Okay? Hopefully that made sense to you. 55 degrees, because again, we figured out, we had to go a little bit backwards to figure it out. This is 90, so this whole thing has to be 90. This is 35, so 35 plus 55 is 90. This is a vertical angle, so they're congruent to each other, so this also has to be the same, 55 degrees. That's one way of figuring it out. Okay, we are not ready to do the guided practice page yet because, like I said, we're going to do this video in two parts. So this was part one, just learning what the different angles names are called and how to measure them and how to figure out things from diagrams. So I'm going to have you working on IXL as an actual homework assignment. This will prepare you for the next lesson, which will be our guided practice and independent practice pages. So it's going to get a little bit tougher. We're going to be using algebra along with our angle measurements. So IXL, I would like you to do, let me grab my little spotlight here. You're going to go under two-dimensional figures. You're going to do number 2, name, measure, and classify angles. You're going to do number 5, identify complementary, supplementary, vertical, adjacent, and congruent angles. And then you're going to do number 17, find measures of complementary, supplementary, vertical, and adjacent angles. All the stuff we've done on this video is what you will be doing. I wanted to see if I can bring that up. Yeah, here it is. So two-dimensional figures. So number 2, grab my spotlight again, right here, name, measure, and classify an angle. It's going to look like that. Number 5, identify complementary, supplementary. Did I say the wrong one here? Oh, 16. Sorry, 16. Identify complementary, supplementary, vertical, adjacent, and congruent angles. So I'll change that. And then number 17, find the measures of complementary, supplementary, vertical, and adjacent angles. So let me go back to that, and this should be number 16. Oop, that's not what I want. So it's not number 5, it's number 16. Okay, so if you have any questions, let me know. This will prepare us and get us ready for our next lesson. So I will stop my share and I will see you guys next time. Bye-bye. Have a good day.